So this is example number 9. Draw a hypocycloid which has been generated by rolling circle of 40 mm diameter inside of a 160 mm directing circle for one complete clockwise revolution. Also draw tangent and normal to this cycloid at a point 60 mm from the center of directing circle. So now we have to draw a hypocycloid here. Hypocycloid which has been generated by a point on the rolling circle of 40 mm diameter, the 160 mm diameter directing circle, and we also have to draw tangent and normal to the cycloid. This is similar to the previous question of epicycloid, but here we need to just observe that we have to roll the rolling circle inside of the directing circle. So we will see now.
So for drawing this hypocycloid, first we have to draw the directing circle which is of diameter 160 mm. So the radius is 80 mm. So I am measuring, I have already drawn the circle with 80 mm radius, as you can see here. I'll just highlight it one more time. So this is your directing circle, and inside this circle one more circle will be there which will roll inside. Because this is a hypocycloid, the circle will roll inside. The difference between in epicycloid, you have seen that the circle was rolling above and the rolling circle is of 40 mm diameter, so its radius will be 20 mm. Before that I am taking one line here so that we know where we are going to start. This line we can take with our own wish, we can take it here, here or here, anywhere. But if we take on this left hand side, we'll get the hypocycloid in this fashion. So it will look somewhat good. And now for drawing this circle, rolling circle, the diameter of which is 40 mm. So the radius is 20 mm. I am keeping the radius as 20 mm, and I am first keeping the pointer at this point where this generating circle and this line is meeting. So now we have the rolling circle. This circle, as I said earlier, this circle will roll inside this directing circle. Now when coming back to our hypocycloid, it will not cover the whole directing circle. It will take only this some small portion, a particular angle which can be found by this formula 360 into r by r, as we did the last time for drawing the epicycloid. So here the small r is 20, the radius of rolling circle. The capital R is the radius of directing circle, which is 80 because the diameter was 160. So this will be equivalent. This angle will be equal to 90 degree. So what we will do is, I am marking 90 degree here. There you go. So this is your 90 degree. So our hypocycloid will come in this portion only. Actually we did not draw this directing circle also, but for your reference I have just drawn this. See that this circle is of 40 mm diameter, and only this portion of the directing circle will be used for drawing the hypocycloid. So as we did in the last time, I will draw the directing locus line first. This is going to be a locus line. This means that the center of the circle will move from this point and along this line till this last point. So I have marked this point O dash O, and this is point A. Now I will divide this portion, this angle, which is 90 degree, and the circle into equal parts. As we did last time, we have divided this circle and angle into 12 equal parts. Here the angle is 90, so 90 by 12 will be equivalent to 7.5. So if this is 90 by 6, 90 by 12 will be equal to 7.5, and you know about the circle, there is no need, because 30 degree each. So you can keep this protector in this fashion or in this fashion anyway, whichever you find convenient. As 0.5 division is not given in this scale, what I will do is I will first mark the distances 30 degrees. See here. And then I will mark 15 degrees. See that this is 15, 15, 15, 15, 15, 15. But now we have to take 7.5. I'm doing it in a longer way. Just what you can do is directly count the angle from here: 1, 2, 3, 4, 5, 6, 7. This is 5, this is 7, this is going to be a 7.5 in this fashion. So if this is 1, 5, 7.5, don't expect accurate, just try to be accurate as much as possible. So this is 5, 7.5 again. So now you know that here you are having 12 different parts: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We will divide this circle also into 12 equal parts. So 360 by 12, as you know, 30 degree. So I'll draw on this side. I'll mark angle on this side. This is 30, 60 and 90. So there you have it: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So you have 12, and We'll mark points here also. So the circle is touching here. I'll start the first point from here. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we have divided this circle into 12 parts, and as we have divided this line also, so we need to number this also, this line also. So this is say line 1 dash, 2 dash, 3 dash, 4 dash, 5 dash, 6 dash, 7 dash, 8 dash, 9 dash, 10 dash, 11 dash, 12 dash. Now we have to draw arcs till they meet this last line. See, if I start from 8, it will touch 4 also. There you have it. If this is O, this is the first line. So this will be your O1, O2, O3, O4, O5, O6, O7, O8, O9, O10, O11, O12. All these centers are coming on the locus line, because if center is here, if the circle rolls in this fashion, the center will move from O to O1, then O2, O3, O4 in a similar fashion. Then take the radius of this circle, that is 20, with center O1. We have to cut the first line, which is so with center O1 and the line number 1 of this, the arc number 1, as you can say, we have cut the arc. So you will get the meeting point here. With center O2, we have to cut the second arc. Similar way, with O3, you have to cut the third arc. With O4, you have to cut the fourth arc. With O5, you have to cut the fifth arc. With O6, we can cut 6th point, where is the 6th arc? Sorry, I haven't taken 6th arc. With O6. Then O7 as center, 7th arc, with O8 as center, 8th arc, with O9, obviously it will touch at the end, with O10, then O12, which will be this last point. So see that I have cut the arc here, 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 and here, here, here. First point with O1 as center I have cut arc. Second point, this is the line which have to be cut from center O2. Now I will start drawing the hypocycloid by joining these points. So you will have hypocycloid in this fashion. So this is your hypocycloid, and this is our exercise number 9. And from the previous question from epicycloid, you see that the only difference is this circle is coming inside the directing circle, and hypocycloid is coming in the fashion U fashion. So this curve is your hypocycloid. Now for drawing the tangent and normal, so we have to take that tangent and normal also at a distance of 60 mm from the directing center of the directing circle. So which means this is the directing center circle, this is the directing circle and center of this circle. So I need to adjust this scale, or else what I can do is I can measure the distance 60 with the compass, and I will cut one arc here. You know that this point is named as M. This point is OA. So this point is actually M, and from here we will get the tangent and the normal. So as you know, just we have to draw a parallel line. With 20, we have to take the radius of 20 mm, and with center M we have to cut the locus we'll get one point here. This point name it as D something D, and we have to draw a line parallel to this. So this is one more point. What we can do is easily now just join these 2 points. I'm doing this with H pencil only because this is my normal N. This portion is NN. This line NN is our normal. And to draw the tangent, keep the drafter one scale with align with N, so that a perpendicular line touching this point only once is our tangent. Hence we have drawn our tangent and normal. This is at a distance of 60 mm away from the center of the directing circle.